Hello everyone, welcome to Probability Lessons. Here we discuss conditional probability. In a random experiment, a card is drawn from a pack of 52 cards. Here are the 52 cards. 4 suits, spades, clubs, both are black, hearts and diamond. Each suit consists of 13 cards. These are the 52 cards and one card is picked up. That is the experiment. Let's consider few events. Event A. The selected card is red card. Selected card is black card, hearts card, spade card, ace card, queen card. These are few events we are going to consider. What are events? Events are subset of sample space. What is sample space? Sample space is set of all possible outcomes of a random experiment. Set of all possible outcomes. These are the 52 possible outcomes. The set of the whole outcomes is called sample space. Now, these are few subsets. The selected card is red card. This subset A consists of the elements, these 26 elements. Subset D, selected card is a spade card. These are the 13 cards belonging to that subset. So each of these conditions make a subset respectively. We are familiar with all these. Now, let's find the probability of each of these events. Probability of A, as the subset of this event consists of 26 cards which are favorable to this condition. 26 out of total 52. That is equal to half. Similarly, probability of B, probability of getting a black card is also 26 by 52. Hearts card, there are 13 of them. So probability of C is 13 by 52. Probability of D is again 13 by 52 as there are 13 spade cards which are favorable to this event. And there are 4 ace cards. Hence, the probability is 4 by 52 for the event E. Event F has the probability again 4 by 52. 4 by 52 is equal to 1 by 13. These are all simple probabilities. Simple probability. Now, we are going to make the condition of the probability of another event. Conditional probability of F when it is given that C has occurred. Conditional probability of the event F when it is given that, when it is known that C has already occurred. What does it mean? The condition says C has already occurred. C has occurred means the selected card is already hearts card. There are 13 cards. So we need to think of only these 13 cards. This has already happened. Now, on the basis of that information, now we need to tell what is the probability of F. Such a probability is called conditional probability. The condition is that C has happened. If C has happened, then what's the probability of F? Okay, let's see. If we already know C has happened, we know the card is one of these 13 cards. Now, out of these 13 cards, what's the chance that the selected card to be queen? That is F. Okay, let's see. There is only one queen in it, one queen. So the probability is this one out of these 13. Notice that we are speaking about only these 13. So the sample space is now considered only this much. Since it is known that C has happened. So the probability will be 1 upon 13. 1 by 13. Now, this is called conditional probability of F given C. F given C. Written like this. And this is read probability of conditional probability of F given C. This is what the introduction of conditional probability. Let's have another example. Find the conditional probability of C when it is given that A has occurred. Now this time the given information is yet another one. A has occurred. What does it mean? The card that has come out in this experiment is already red, one of these. So we need to this time think of only these 26 cards. Now under this information that is given to us that A has occurred, now we need to find the probability of C. What is C? C is getting a hard card. So once you know that the card that has come out is red card, what chance is there that it is hearts card? Okay, there are 26 red cards, out of which these 13 are hearts. So this conditional probability will be these 13 divided by 26 out of these 26. So 13 by 26 is the conditional probability, which is simplified into half. So this is denoted as conditional probability of C given A. The given condition, given information is A. That is written after the slash. This is conditional probability of C given A. We have already calculated, it is half. Now, this way the conditional probabilities are calculated to understand the meaning of conditional probability. But we have a formula also to calculate the conditional probability. We can get these answers using that conditional probability. The formula is probability of any event A and B taken, then the conditional probability of A given B is denoted as probability of A given B, which is equal to probability of A intersection B upon probability of B. This is a formula. Now notice that both numerator and denominator are simple probabilities. So this time this formula is going to depend on the ratio of two simple probabilities. A intersection B means probability of both events happening, A and B happening. That is what intersection, common elements. Let's try to find the answer, this answer which we have already calculated by analyzing. Let's try to get it by this formula. Had we gone by this formula, probability of F given C would get the formula probability of F intersection C upon probability of C. Applying this formula, look, the given condition B, its probability is the denominator. Given condition C should be the probability of the denominator. And the numerator is probability of the common element to F and C. Now let's see, this is equal to the denominator, simple probability of C. Simple probability of C we had already done. That is 13 by 52. That is what's the probability of getting hearts? This is it. 13 by 52. Remember, the denominator is a simple probability. So consider the complete sample space. Simple probabilities are calculated on the basis of the complete sample space, not the restricted one. So the denominator, the simple probability of C is 13 by 52. Now, what is a numerator? That is again a simple probability. Simple probability of F intersection C, which means what is the probability of happening F and C? F and C. What is F? Queen. What is C? Hearts. Hearts and queen. How many cards are there which are hearts as well as queen? Yes, there is only one card that is hearts as well as queen. There are 4 queens, there are 13 hearts, but this is the only card which is hearts as well as queen. So 1 by 52 will be the numerator, the common element. Now look at this. These two simple probability are put into a ratio according to the formula. By simplifying it, of course, the 52 common denominator, if you cancel, we get the answer 1 by 13, which is what we had already calculated. One more additional information about it. Sometimes probability of any event, say in this case, probability of F is calculated. We were calculating the probability of F only, but We did that under the information that C has happened. That is why it became conditional probability. Otherwise, this event F had a simple probability also. Look, here simple probability was already 1 by 13. By providing a condition that C has occurred, then also the probability is 1 by 13. Conditional probability is 1 by 13 and simple probability was also 1 by 13. That is the speciality of these two events here. In case two events behave like this, that is, conditional probability of an event happens to be equal to the simple probability of that event, then those two events are called independent events. That means happening of one of them does not influence the probability of the other one. Whether C has occurred or not, whether we knew whether C has occurred or not, probability of would remain same as 1 by 13 earlier, 1 by 13 later. But remember, this doesn't happen so always with all other events. Sometimes the given information influences the probability of another information, another event. Let's take the second that we already considered earlier. Probability of C given A. The probability was calculated to be half. Now, let's go by the formula also. According to the formula, probability of C given A should be probability of C intersection A upon probability of A. Denominator probability of A, the simple probability of A is 26 by 52. Here it is. And the common element to C and A. Common element to C and A, heart and red. How many cards are hearts as well as red? Okay. These are the 13 cards which are heart as well as red. So here we get the numerator 13 by 52. Look. Here, simplified further, 52 denominator common, so 13 by 26 which is equal to half. We have calculated the conditional probability by the formula. Now let's see. Here we were calculating the probability of C under the given information that A has happened. If this information was not given, the probability of C would have been a simple probability. That time that was 1 by 4. But by giving the information that A has happened, the probability of C, the 1 by 4, changed to 1 by 2. Therefore, these two events, C and A, are not independent. We will be discussing this topic independent little later.